First thing, I do want you to make sure that you have opened up the link in Canvas called the Desmos Sketch to the Trig Transformation Sliders. That should take you here. What you'll see is a sine graph. If you want, you can turn on a cosine graph. Looking at either one or both is going to show you what we want to see. So pick whichever one you like. I'm going to stick with sine here to start. And notice where the sliders are. We've got A at 1 and B at 1, and then C and D are both at 0. Every time we reset, that's where they should go. So 1, 1, 0, 0, this is your standard sine graph. What we want to investigate is what do the A, B, C, and D do? So at this point, if you haven't already played around with them, do a quick pause, play around with them, see what they do, and then we'll come back together in just a moment. Hoping that you have done that, a pause and an exploration, the first question we want to answer is, what makes our graph stretch or compress vertically? So up and down. So reset your sliders to A and B are 1, C and D are 0, and see if you can figure out which one or which combination affects how tall and short your graph is. I hope without too much trouble I can convince you the only one that affects that is your A. You can make your graph be very tall and stretched out. You can make your graph be very compressed and short by dealing with that A value. So there it is. That's what A does. Now, when we're looking at a graph, I'm going to pull up this example down here. I want to talk about a couple of terms. The first term is midline. The midline is a horizontal line that goes straight through the center of your sine or cosine graph, exactly halfway between a maximum and a minimum. So the midline is kind of like the average between the high and the low. The distance from that midline to a maximum point or to a minimum point is called the amplitude. Now, the amplitude is a distance, so it's always a positive number. The question is, how do you figure out what the amplitude is? Let's head back to the Desmos here for a moment. So right now I've got my A as the number 3.4. If I click on here, I can see that on my graph, the highest it goes is positive 3.4. The lowest it goes is negative 3.4. That means the amplitude, distance from 0 to the top or 0 to the bottom, is 3.4. That was the value of A. I wonder if that's a coincidence. Let's go down here. Let's make A something negative. How about like negative 5.5? Take a look at my graph. It goes up to a height of 5.5, down to a low of negative 5.5. So once again, this A value is showing up. And it really is that simple. The amplitude of your graph isn't A, but it's rather the absolute value of A. We put the absolute values in because A can be negative, but amplitude is always a positive number. So I want you to do a little bit more investigation and see if you can answer these questions for me. What values of A cause your graph of sine or cosine to flip upside down? Let's start there. Okay, see if you get what I got. So here, I'm going to go back to my regular window, my regular sine function. If I make my A bigger, graph is not flipping upside down. But if I go down low enough, now suddenly things are flipped upside down. And that switch happens right at 0. It's the negative A's that are flipping things over. So your graph is reflected vertically if your A is negative. Now let's talk about what sorts of values make your graph stretch and what make them shrink. I'm going to put in just a regular sine graph for reference. Make it orange. So I noticed that like right here, my graphs are the same. Now I'm stretching it out. But here in the middle, I'm getting values that actually shrink it down a little bit. We call that a compression or a shrink, making it go smaller. And take a look at what values are making that happen. So your graph gets compressed as long as your A values aren't that big. Specifically, they need to be between -1 and +1. What shrinks your graph down, compresses vertically, is if the size of your A number is less than 1. Conversely, if your A size is bigger than 1, your graph will stretch. I hope that makes a little bit of sense. Multiply by a number bigger than 1, your result gets bigger. Multiply by a number that's a tiny fraction or decimal, your result gets smaller. One of the things you'll be asked to do in your practice is, given an equation, find the amplitude of the graph. It really is this simple. You want to look at the A number, which will be the multiplier right in front of your trig function. The amplitude is always the absolute value of that number. So in this particular case, it's 2. So whatever this graph looks like, from the midline, if you go up 2 and if you go down 2, that's what's going to give you your maximum and your minimum. Over here, same deal. Take a look at the multiplier right in front of your trig function. This time it's a fraction, so it'll be a compression, but the amplitude is simply the absolute value of that 1/8, which is 1/8. So same idea. Whatever this graph looks like, if I go from the midline to a maximum and a minimum, this distance is going to be that 1/8.